in that particular case, what I am trying to say, this is nothing but simplification of CFG. Simplification of CFG. Simplification of CFG, context free grammar. So the first thing that you have to, that means to if you want to build compiler, right? If you want to build compiler, so what we have to do first, you have to build grammar, right? You have to build grammar. Then what you have to do, then you have to remove useless symbol. You have to remove useless, you have to remove useless symbols. So the first thing we will do step by step, and we will see how to eliminate epsilon productions, how to eliminate unit productions, how to eliminate useless productions step by step. Okay, that means remove useless symbols. You have to remove epsilon productions, you have to remove unit productions. So the thing is that then there should be some procedure to build the compiler. So the thing is that first we will start from how to elimination of epsilon productions. This is the simplification of CFG, and we will start it by elimination of epsilon production, elimination of epsilon productions. So the thing is that, what do you mean by that? Means when a is this is a non-terminal and you will get epsilon. So epsilon production is going to harm the process of derivations, like, because you cannot track the length of the string. You will see in the previous class. That means what is the problem? That means this epsilon production is going to harm the process of derivation, the process of derivation. We might growth the string. What is the problem? That we might growth the string. We might growth the string length up to certain length, up to certain length, and again shrink it, right? And again shrink it, and because of that, and because of that, we are not able to decide, we are not able to decide till what length we grow the derivations. We grow the derivations because the length will be shrinking, and again it will be increases. Now if you want to say that you have to produce the string length 5 or 6, so how much take it will take, you don't know, because there will be epsilon production. So what length we grow, the derivation procedure, derivation procedure before before stopping, and saying that, before stopping and saying that this string could not this string could not be generated. That is the problem. Could not be generated. Since there is a hope of syncing, we are doing again and again, right? Because there is a hope of syncing, so since there is a hope of shrinking, we are doing again and again. We are doing again and again. So just to avoid it, we want to eliminate. We want to eliminate epsilon productions. We want to eliminate epsilon productions. If eliminate all epsilon productions, if the language itself contain epsilon, then there is a different procedure. But other is we are not, of course, just to avoid, we are doing again and again. So just to avoid, we want to eliminate all epsilon productions, right? But it is not possible always. But we are not able to eliminate. We are not able to eliminate, of course, all epsilon productions if the language itself called epsilon, contain epsilon. That means eliminate all epsilon productions, if the language itself contain, epsilon. That is the case. That means we are not able to eliminate all epsilon productions if the language itself contain epsilon. So the thing is that, say I am writing S to ASB and AAB, right there, and from A to epsilon. So the thing is, I have to find out all the null productions and nullable variable. We have to first find out all the nullable production and nullable variables. So what is this? That means if we say that, say I am taking example like S from ASB, right? That in the previous one I am written here, but I am just giving extra thing from A to epsilon. So what we know in that particular case, that A is producing epsilon, right? So in that particular case, this nullable variable is nothing but A, because A produces epsilon. So to eliminate epsilon productions, you can put epsilon on the right side. We can put epsilon on the right side of the production. Right side of the productions. Write that what we can say from S, say ASB, and this is, I am just removing, eliminate the epsilon productions. Now you can see, if it may be possible there is no AB, then what we can say in the first case, say there is no AB, right? Then it would be understandable. Then if we put A equals to epsilon in that, so what we will get, this AAB and AB. That means first what we can say, I am just putting epsilon in all the productions. These productions are remaining, and with that, after putting the epsilon, what are the things that we generate, that also included in the rule. So next we have to check, you just see from the figure, from S, from S, A is reachable or not, that we have to say, because what we can say, from S, if we generate like AAB, right, then we cannot do anything because we cannot generate terminals. What I am saying, that means from the start state we should reach to a terminal string, but if we just write AAB, we cannot reach to the terminal string, right, because there is no rules which can substitute the value of A. So what we can say, since we are not generating terminal, so A is not, we can say not reachable. This A is not reachable. So you can remove the rules যেটা start state থেকে reachable হয় না. So finally what I am getting from S, the final rule that we will get, that is nothing but this, right? So if we take another example, then it will be more clear to all of you. So thing is that, let's say I am taking example. If you have some problem with the example, tell me that A will produce say AAA and epsilon, and say B will produce B, say BB, epsilon. So first we have to find the nullable variable. That means from A we can generate epsilon, from B we can generate epsilon, and if A and B both will generate epsilon, then also S can generate epsilon. So if we consider the nullable variables, that is nothing but A, B and S, because from A we can generate epsilon, from B we can generate epsilon, and from S we can also generate epsilon, because from A and B we can generate epsilon. So whenever now whenever S is, that means this is the start state, S is nullable, then that means epsilon is belongs to the language, right? What I am saying, if H is also generating epsilon, that means epsilon is belongs to the language, so you cannot eliminate all non-productions, right? So from that what we can say, we cannot eliminate all null productions. We cannot eliminate all null productions. So what we can say, we are just putting A equals to epsilon and B equals to epsilon. So we know from A, this is AB, right? What I am saying, in place of A we are putting epsilon, then we will get only B. Now in place of B, if we put epsilon, that we will get A, and if we put both epsilon to S, we will get epsilon. So the language itself called an epsilon. Now from A, that is what I am saying, this is AA, we have to remain, and then in place of A, if we place epsilon, then we get this, and in place of 2A, if we place 2 epsilon, then we will get A. So this is the rule. And from B also, this is BBB, that is remains. In place of B, in place of this B, if we can place 1 epsilon, then this is BB. Now if we place 2 epsilon, then we will get B. So the corresponding the grammar, because you cannot eliminate all the epsilon, you can see that from there, but at least you are removing the epsilon from A and B, and the corresponding grammars is like that. Let's take another example such that it makes it clear. That is the easiest thing, that is the bolo
স্যার
bolo
স্যার বলছি মানে এপসাইলন কোনো একটাতে থাকলেও আর প্রবলেম নেই, কোনো একটাতে এপসাইলন থাকলেও আর প্রবলেম হবে না, তাই তো?
না, আমার একটাতে আমি যদি রিমুভ করতে না পারি তাহলে তো আমার কিছু,
যেরকম আপনি এসে
হ্যাঁ, এসে যদি এপসাইলন হয়, আমার তো কিছু করার নেই। ল্যাঙ্গুয়েজটা যদি ইটসেলফ কন্টেইন করে এপসাইলন, দেন আই হ্যাভ নাথিং টু ডু উইথ দ্যাট। মানে প্রবলেম হলেও কিছু করার নেই, মানে ল্যাঙ্গুয়েজটার মধ্যেই তো এপসাইলন আছে, রাইট? You cannot remove all the stuff. So that is that. Asha, can you say me that what are the nullable symbol of this production rule? নিজেরা বলো দেখি।
স্যার বি আর সি।
Nullable
স্যার বি আর সি।
okay, nullable symbols you can তুমি বলছো that should be BC, right? কেন A হবে না? B তেও তো এপসাইলন আছে, C তেও এপসাইলন আছে, A is
হ্যাঁ স্যার, স্যার হবে হবে,
that means A is
স্যার
equal
হবে,
to
এস ও হবে, এ ও।
yes and তাহলে যদি আমার এটা যদি S কি করে হবে? S তো কি করেই হবে না, কারণ S এ তো টার্মিনাল আছে।
ও মানে হ্যাঁ ঠিক আছে ঠিক আছে, হ্যাঁ টার্মিনাল আছে,
টার্মিনাল
বি আর এ
আছে,
আছে, হ্যাঁ
ওকে। সো
স্মল
এবারে
বি স্মল এ আছে, হ্যাঁ।
এবারে প্রোডাকশন রুট গুলো বলো কি লিখবে? এটা তো থাকলোই A B A C, then what we can say in place of C we can place epsilon, যদি C তে epsilon বসাও তাহলে A B A। এবারে এই রুলে যদি A তে epsilon বসাও, রাইট, যদি A তে তুমি epsilon বসাও তাহলে আমার এখানে BAC, রাইট, BAC, and যদি দুটোতেই epsilon বসাও we will get BA, right? From A we can produce B and C, যদি B তে epsilon বসাও শুধু C থাকবে, যদি C তে epsilon বসাও শুধু B থাকবে। The thing is from B we will be getting B, from C we are getting from D, and from D we are getting D, small d. So the thing is that I am getting this, right? I am getting this production rule, right, from that. That is a simple, if you want to remove the epsilon, I know that if any examples is given to you, you can solve it. Now there is, uh, just see that if we eliminate epsilon productions, we are, you are including the unit productions, right? That is the problem. That means when you are just eliminating the, the epsilon productions, from A to C, from A to B, and from C to D, these production three rules are, and there are unit productions, that this is, unit productions, and you will also face the same problem with the unit productions, right? So what I'm saying, just look carefully that, just see, that elimination, elimination, of epsilon production, that is important in for your, markout that will come. That means if just see if the elimination of epsilon productions, that will, introduce unit productions, that will introduce, unit productions, like that, A to B, or A to C, or C to D, all are unit productions. But unit production is also useless, but unit production, unit production is also useless. Because why it is useless? Because you just see, if we substitute it with B, right, then if we can substitute with C, and again we are substituting with by D, that means in each derivation, that means in, if we say derivation each derivation, the length of the string, the length of, the string, or the terminals, or the, terminals are not increasing, are not increasing. So it is useless because of the same reasons. That means, you know uh, when we have to stop, that could not be understand. That means, in that particular case we are not able to decide till what length we have to grow the derivation procedure before stopping. You are saying that your program will stop after, the string length of 10, say, but to reach string length 10 it may take infinite amount of time, because if you are using null productions, epsilon productions, and if there are, unit productions, then you don't know that when it will stop. So that is the problem. So the next task, that is, you have to eliminate, eliminate unit productions. So the next task, you have to eliminate, unit production. You have to eliminate unit production. So any number of transformations cannot change the language generation. What is the problem? That means any number of transformation, any number of, you know transformation, that actually cannot change the language generation. That will, any number of transformations cannot change the language generation. So the thing is that in that particular case, say, the grammar is like that: a to b to b a to, bc to b. First you have to remove the unit productions, right? First remove unit production. First you have to remove, unit production. So if you can remove the unit productions, then what you can say: from a to a, from b to bb, and from a to small a, either bc. So you will get that, right? So now since you are deleting s to b, you delete from s to b. So I have to check, if we delete these productions, then what the corresponding terminals we can reach. That means if we, from s to b, and from b to, we can reach bb, right? We can reach bb. Or from s to b, if we go to s to b, then from b to a we can again get to a, and from a we can generate a or b. So we can generate, a or bc. So what you can say, that you can add this, you can add it. That means what we can add, that means, from, this is s, I think I'm writing wrong, this is s. So the thing is that from s, as well as we can generate aa, but also we can generate bb, also we can generate a, or also we can generate bc, right? So the thing is that we can say, and since we are removing, from b to a, that means b to a means from a we can either go to a, or either we can go to bc. So from b I can either go to, bb, or a, or bc, right? So I can remove this, b to a, and also, there is a to b. I have to another rule, that is from, a to b. So from b we can either go from bb, or either we can go a, or either we can go bc. So if you want to remove this rule, from a, this is a, either bb, either bc. So the total rule is these three rules. That means we are eliminating the unit productions, and after eliminating the unit productions, what we can get, we are getting these three rules, right? Let's see another example, then it would be more clearer to all of you. The thing is that, say I'm taking another example, look it carefully. That means it is given, say s to ab, say a to a, b to c or b, c to d, d to, e, and e to a, right? So the thing is that, what we can say about that. So what are the unit productions? B to c, this is a unit production. C to d, d to e, that three are, generating the unit productions. So the thing is that, what I am writing, the new rules is to AB, and from A to A, and from B what we will get, you just see, from B to C I am writing here, from B to C, right, B to C. So from C to D we can get, because we are getting terminal, we have to get the terminal. So from B to C, C to D, and D to E, and D to E, and from E to A we are getting A, right. So from B, if we replace B to C, then we can write another rule. That means we can generate A, and already B is there. Now you can say that C to D, if we remove C to D, D to E, E to A, so we can say C to A, right. And from there is another rule, this is D to E. D to E means D to we can get A. So if we remove this D to E, then we will get D to A. So the thing is that is the E to A is already been there. So that is the grammars that we can we find after removing the unit productions, after removing the unit productions. So now we are eliminating the useless productions. Now we want to eliminate the useless productions. So what do you mean by useless production? So in the previous example, just carefully if you see the productions rule, that after eliminating the unit productions, what we will get from S to AB, that is right. But from S, we are not able to generate terminals using C, D and E, right? A to B, because there is no relations. That means from S, we are not able to generate terminals using C and D or E, because there is no relations. From S there is AB, but there is no relation. That means from starting string you cannot generate C, D, E, right? So of course you can say C, D, E are useless, right? Because এই productions rule টা তো তুমি start step থেকে কোনোবার আসতেই পারবে না. So what we will see, that means in this previous example, in this previous example, what we will see, that from this S to AB, in this production from S to AB, we are not able to generate terminals. We are not able to generate terminals using C, D or E, right? So the thing is that are useless. So what we can say, this C, D, E that are useless, that are useless. So the thing is that what we can say about that, if we define rules, that means every variable, or you can say non-terminal, whatever be the thing, every variable or non-terminal should derive some part, of the string, some part of the strings. And the second thing that you can say, every variable should be reachable from start state. That means every variables should reachable from start state. Every variable should reachable from start state. So that means the thing is that if we write say S to AB or A, from A to BC or B, from B to AB or C, from C to AC or B. So here the terminals is only small a and small b. If you talk about the non-terminals, that is S, A, B C. So terminals are always useful. Terminals are always useful. So how can we get it? That means first the thing is that every variable should derive some part. So first thing is that of course the terminals are always useful. So if we make a set, we are introducing AB. Now we will see that you know whether from S we can generate terminal or not. From S there is a we can generate the terminals, so there is not an issue. So S can be introduced, and from A we can also generate B, right? Small b, we can generate small b, so we can generate terminal. So you know we can include this A. Now the thing is that there is no way to generate the strings you know B or C from S, right? We cannot generate because from B what we can see, we are generating C or AB, and from C we are generating AC or B. That means B and C, B and C, it cannot be replaced by just if we write like that B AB. Again you are substituting from B we are getting C, from C we can get B again, like that. That means you cannot generate terminals, right? That means you cannot generate string from B or C from S. If you start from S and you replace B and C, you cannot generate string, right? Because if we say we are starting from S, there is AB. Say in place of A we are placing B, so in place of B either we have to substitute AB, or either you have to substitute C, either you can substitute in C, I can say C, or in place of C I can substitute B. That means from start state is you cannot generate string, right? You cannot generate string by these productions. So of course this B and C are useless. Okay, so you have to delete all the productions which containing B and C, right? That means there is no way there is no way to generate strings from you know generate string from S through B or C, right? So this B and C that are useless. If you are determined it as a useless, that means you have to delete all the productions. You have to delete all the productions containing B and C, right? B and C, you have to delete all the productions containing B and C. So what I am saying, so if we want to delete all the productions that will containing B and C, that means this particular productions will be deleted, this is also deleted, this is deleted, this is deleted. That means the remaining thing that we will get from S to A, and of course A to B, right? That, but these productions that we will get, and you see that from the productions of course A is not reachable, right? We cannot, A is not reachable from S, S থেকে আমি এতে আসতে পারি না. So you can also remove these productions. So the only productions that remain, that from S to A, right? So that will happen, that will happen. That is the important thing. So if I give you an example, tell me by careful observations that what are the rules. That means I am giving you AB to AC, from A, AAB, BAA or A, from B, say BBA, AA B A B C A B C A A D B. From D we will get B D or A C. So that is the corresponding, you can think, that is the corresponding set of rules. And of course in that particular case the terminals that we get AB, and the non-terminals that we get from S, A, B, C, D. So tell me, or let's do it together. I will give you another home task that you can solve at home. Say what the process, that means first you have to add terminals, that is the corresponding process. That means you have to first add terminals, right? Terminals. Now see the right side of the production. Now in the second step what you have to do, see the right hand side, that means see you know right side of production, right side of production generating AB, right? Generating AB. That means right side of the production generating AB, you will see A will generate this small a, right? And I am writing A, B and A. Now using this, now your set will contain A, B and A. So now using this, see whether you can you know generate any terminals or not. You can generate any terminals or not, right? So the thing is that right side, I have to see the right side. This is a terminal, this is terminal, and this is A. A is also taken as a set. So from B you can generate the terminals. So AB is there, A is there, also B is should be included. You and the thing is that the same way I can proceed in the next step. What we will see from the right side, A and B are included. That means you can generate S also. So you can generate AB, and you can also generate S also. So now you will see that ABCA, there is a C, so you cannot generate this, or there is a ADB, you cannot generate this. From D you cannot generate this. So these are the set that are useful. So from that what you can say, so this C and D that are not useful, that are not useful. And you have to say that since these are not useful, you have to remove these productions. If you can remove these productions, so S, this is AB, because there is AC, so this is not included. From A there is AAB, BAA or A. From B there is BBA, AAB or AB, and that are removed, that all productions. So we will get this. And useful productions, all are reachable from start state. From A to B, right, that we are getting A and we are getting B, that means all are reachable. So the thing is that from the start state, so that's all, so the thing is that we can generate like that. So that is your home task. You can try it, A B C, B A B, from A to A, B A C, A A A, from B B, 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 A. From C, this is CA or AC. So these are the corresponding, and set of terminals, that is, AB. In set of non-terminals, capital A, B, C. I think these three are given. So you can do it that as a, you can take as a complex, and whether you can solve it or not, let's see later.